Cold water always freezes faster than hot water, right? Not always. Under the right conditions, a cup of hot water dropped into a freezer turns to ice before an identical cup of cold water started at the exact same moment. It sounds like a trick, but it's a real documented phenomenon, and it's been driving scientists a little crazy for decades. It's called the Mpemba effect, named after a Tanzanian student, Erasto Mpemba, who first noticed it in the 1960s while making ice cream in a school cooking class. He noticed his hot mixture froze before a classmate's cooler one, and when he brought it up, his teachers laughed at him. It sounded like nonsense. Everyone knows cold water has less distance to travel to reach freezing. But Mpemba kept asking, and eventually a visiting physicist took the question seriously enough to test it in a lab. The effect held up, at least sometimes. That sometimes is the whole story here, and it's more interesting than a clean yes or no answer would be. Several different physical effects seem to compete to produce it. Hot water evaporates faster than cold water, so by the time both samples reach a shared temperature, the hot one has literally lost some of its mass. There's simply less liquid left that needs to turn solid. Hot water can also lose dissolved gases as it heats, and those gases, when present, interfere with how ice crystals form. Less dissolved gas can mean a cleaner, faster path to freezing. Think of how a hot cup of coffee steams and cools rapidly on a countertop, shedding heat and moisture into the air far faster than a lukewarm mug ever would. Hot water sitting in a freezer is doing something similar, just sped up by the cold air pressing in from every side. Then there's motion. A hot container of water isn't sitting still on the inside. Heat drives convection currents, layers of warmer and cooler liquid circulating and swapping places. Those currents can cool the surface layer unevenly, sometimes fast enough to kick off ice formation sooner than a colder, calmer cup ever manages. Cold water, sitting near a stable temperature already, doesn't have nearly as much internal churn working in its favor. It's a bit like the difference between a still pond and a pond being stirred by wind. The stirred one exchanges heat with the air around it far more efficiently, simply because more of the liquid keeps cycling past the surface. Here's the part that trips people up though. None of this happens every single time. Change the shape of the container, the purity of the water, or the exact starting temperatures, and the effect can shrink, vanish, or flip entirely. Some carefully controlled experiments show the Mpemba effect clearly and repeatably. Others, run under slightly different conditions, show almost no difference between the two cups at all. For years, that inconsistency made some scientists suspicious that the whole thing was measurement error dressed up as physics. But that inconsistency might actually be the real discovery. It means freezing isn't the single predictable countdown most of us assume, temperature dropping steadily until it crosses a line. Instead, evaporation, gas content, convection, and container geometry are all competing simultaneously, and depending on which one has the upper hand, the outcome can shift. Simple systems that behave in complicated, condition-dependent ways tend to be where physics gets genuinely interesting, and a glass of water sitting in a freezer turns out to be exactly one of those systems. What I find genuinely striking is that this wasn't uncovered by an elite research team with a grant and a lab full of equipment. It came from a teenager's kitchen observation that adults dismissed on the spot. Erasto Mpemba wasn't wrong. He just noticed something everyone else had assumed away without ever checking. So next time somebody insists cold water always wins the race to freezing, remember, a curious teenager with an ice cream maker already proved that assumption wrong in front of a very confused physics class. Sometimes the hotter start really does win. If that blew your mind a little, follow for more.